chapter 3. This is actually the last section of chapter 3. Trig has a lot of really short chapters in it. So we will probably today and tomorrow on this section for sure. I'm thinking possibly test end of the week because we have that 3-day weekend. Because Monday we have staff development. So I don't think we want to come back Tuesday and try to do a test. So we'll probably try to squeeze that in this week, Friday. I don't think it'll be too hard, so we don't have this section. And then obviously we'll have to make a new plan for you since you'll be gone, but we'll figure out something. So we are looking at linear and angular velocity. So a couple more formulas. So far we have the S equals R theta and the area circle A equals 1/2 R squared theta. I am adding a few more formulas today. These are all common formulas in trig. I will not make you memorize them, so on the test, I'm probably just going to give you a formula sheet that has all these formulas on it. I'm not going to tell you what the variables stand for on those formulas. I'll just list them and you should be familiar enough with them that you can use them. Just like with the other two formulas we found, theta always has to be in radians. You cannot use any of these formulas if you have a degree measurement. So always convert things to radians. The first one is linear velocity. So it is called V is the formula we use for it. And it's S over T. So velocity is like speed. Okay. A linear speed, that's what you're used to thinking about when you see a distance or a speed given. Like if you're finding the speed of your car, just how far you go divided by how long it takes you, right? Distance divided by time. So S here, if we're talking about distance on a circle, so linear velocity is saying how fast does some point travel around the outside of the circle. How fast is that point moving? So it's just your distance that you traveled on the outside of the circle, which is arc length, divided by the amount of time it takes you to do it. When you are finding those, your units are going to be like a linear distance. Centimeters per second, or inches per minute, or yards per hour, or something like that. So your S, arc length, is a linear measure. Inches, centimeters, feet, yards, miles, time, minutes, hours, or seconds. So when we see, even if I don't specifically say linear velocity, when I see units like this, that tells me it is a linear velocity. The second speed that we can find is how fast an angle is changing in our circle. So if I have a circle and some point P that's moving around the circle, I could be measuring how fast it moves around the outside, or I could be looking at how fast this angle is changing on the inside. As it spins, my angle is changing. That, if I want to know how fast that angle is moving, that is angular velocity. So angular velocity, it looks like a W, it's actually a Greek letter, omega, equals theta over T. Theta is your angle, T is your time. Big thing, these must be in radians in order to work. So your units, if theta is in radians, you're going to see like radians per second or radians per minute. If you are given something in degrees or revolutions, those are still going to be an angular velocity, but you would just have to convert them first. They would have to be changed into radians before we could do anything else. All right. So those are the first two formulas. The second thing that we want to look at is how those pieces are related. So what we already know is in a circle, arc length is R times theta. Right. So if we use the first formula, V equals S over T, and we substitute in S is R theta. What is theta over T? Theta over T is angular velocity, or the omega. So this is the third formula we're using today. V equals R omega. I did include on the next slide just kind of a summary. This is this little snapshot from your book. It lists this V equals R theta over T, kind of that in-between formula. You're welcome to use it, but I really don't, and I'm not going to give you that one on test or quiz. It's fairly unnecessary if we have the others. So these are the ones that we're going to be looking at. All right, so now let's just try some problems. So if we have a point on a circle with a radius of 15, what variable do we use for radius? It was 15 inches. And it's rotating with an angular speed of pi over 12 radians per second. What variable is angular speed? Omega, the W looking thing. So that's my pi over 12. So part A, find the angle. So if I'm looking for an angle, I'm looking for theta. Generated by P in 10 seconds. So my time is 10 seconds. I like to list everything I have. Whether or not you write units beside these numbers is up to you. I would like for you to put units on your final answer. You should also do a quick check, make sure your units match. Like if one thing was in seconds and one was in minutes, we would need to convert them to match. But we're okay here, everything's in seconds. So I need a formula. The formulas we have so far, or not really so far, all we're going to have. The ones from before, S equals R theta, A equals 1/2 R squared theta. And then our new ones, V equals S over T, omega equals theta over T, V equals R omega. So I'm wanting to find theta. So I need a formula that has theta in it. Okay, so looking at things that have theta. Okay, I'm not finding any areas, so that's not helpful. Now, which of these do I have? Do I have the S to do S equals R theta? No. Do we have omega to do omega equals theta over T? Yes. So because there are multiple formulas, it's helpful to me, and probably you if you write down what formula you're using on these. So omega is pi over 12 equals theta over T, which was 10. So if we multiply over the 10, keep it in terms of pi, if at all possible. So 10 pi over 12 or 5 pi over 6. Part B. Find the distance traveled by P along the circle. What variable is distance along a circle? So I'm looking for S. And we're still talking about 10 seconds. Okay, so my options. I need a formula with S. S equals R theta. Do we have R? Yeah, do we have theta? We actually, we can. We found it in part A, so we could use that. My other option with S is V equals S over T. So I don't have V, so I think the easiest option would be S equals R theta here. So my radius is 15. Theta is 5 pi over 6. So leave it in terms of pi. Just do 15 times 5 over 6. So we get 25 pi over 2. What would my units be? Only the speeds are in radians per second. So the V and the omega, their units are going to be rates. S is just a distance on the outside of the circle, so its units are always the same as the R, which is inches. Another option, if it's hard to pick out units, you can write them in the problem. I don't know if it's more or less confusing for you guys. But R was 15 inches. My theta, that was in radians. Radians are kind of like the extra unit. If you don't have a unit, we call it radians. If we have anything else, the radians goes away. So when you took inches times radians, we just get inches. Linear speed. So linear speed is V. So we can do two options. We have V equals S over T. Do I have S? Yeah, do I have T? Yep, so we could do that if we use the previous problem. Or we can do V equals R omega. Do we have R? Yep, do we have omega? Yes, so two different ways. Do you want to divide or multiply? Let's multiply. V equals, so my radius. R was 15 inches. Omega was pi over 12 radians per second. So if you take 15 times pi over 12, we get 5 pi over 4. If you are struggling with the units, you could think, okay, 15 was in inches. This was radians per second. So when I multiply them, the radians goes away, so it's inches per second. Linear velocity is a linear distance, the inches, per time, so seconds. Questions on that one?
If we round in the primitive problems, could we still use the answers that we rounded?
It will throw off your answer some. So if at all possible, try to avoid it. That's why I'm trying to keep the pi in my answer and keep it as a fraction just so it's more exact. But there will be situations where the only way to get it might be to use the previous answer. So if you had to put it in, just make sure you're keeping like 4 decimal places or so to make it as exact as possible. Other questions? Why don't you guys take, well, no, let's do this one together. Okay? All right. So a belt runs a pulley of radius 5 inches. And the radius is 5 inches. At 120 revolutions per minute. Part A is wanting the angular speed. Angular speed is your omega. We know it makes 120 revolutions per minute. So there's a couple different ways we could do this. This is kind of like an omega, you just have to change it into radians per second, like I asked for. Or we can kind of break it down. A revolution is all the way around the circle. If you go all the way around the circle 120 times, your angle becomes what? How many radians is it to go all the way around the circle? 2 pi. So if we do that 120 times, we could say the angle is 240 pi. And that was in 1 minute, so my time is 1 minute. But I want it in radians per second, so instead of 1 minute, what should I use for my time? So omega equals theta over t. So I have my theta in radians, 240 pi. My t is in seconds, so divided by 60. And we get 4 pi. And in our units, theta was in radians, t was in seconds, so radians per second. Okay, take a second and see if you can do part B. Looking for B. Which formula did you use? R omega. So the radius was 5 inches, and omega was 4 pi. So 5 times 4 pi is 20 pi. If you're struggling with units, you can go back and think the radius was in inches, and if it's a speed, it has to be per time. So we were in seconds. So 25 inches per second. Did we get that one? A satellite traveling in a circular orbit 1,600 kilometers above the surface of the Earth takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. So part A, I want the linear speed. So linear speed is v. I have to figure out what information I have. What do we know? What information is given? Do you know if you can think of anything that we're given? Radius. We know the radius of the Earth to get to the center of the Earth, 6,400, but we are an additional 1,600 beyond that. So if you add those together, is 8,000. Okay, what other piece of information did we have? It takes 2 hours, so hours would be a time to make an orbit. What's an orbit mean? So if you go all the way around, what's your angle? 360 degrees, and we always do radians, which would be 2 pi. All right, so I have 2 options for v. V equals s over t, but I don't have s. Or v equals r omega, but I don't have omega. So either way, I'm going to have to do 2 formulas here. Let's say I wanted to do v equals s over t. So first I have to find s. What formula could we use to find our s? pi kilometers. So now we can do V equals S over T. S is 16,000 pi kilometers divided by T, which was 2 hours. We get 8,000 pi kilometers per hour. So labeling your variables and writing out your formulas is very, very helpful. B, approximate the distance the satellite travels. The distance the satellite travels, what variable would that be? S. So I'm looking for S in 4.5 hours. So my time is 4.5. Why is it not the same S as I had in part A? The time changed. In part A, it was only for 2 hours. So we need an S. We look, S equals R theta. We have the radius still. We could figure out our angle. Or we could do V equals S over T. Is the speed of the satellite changing? No. So if we use that, our speed was 8,000 pi kilometers equals S over 4.5. So if we multiply that over, pi. And my units for S are always the same as the radius, it's just kilometers. Is that one okay? Try a couple more. Find the angular speed. The angular speed is which variable? Of the minute hand of a clock. I gave you very little information here. We know omega equals theta over t. What we have to do here is just pick a theta and a t that correspond to one another. Okay, I didn't even tell you what unit. So there's several different correct answers here, which is part of the reason it's so important to label your answers. So I would pick a nice angle. So maybe 2 pi, all the way around the circle. If I'm talking about the minute hand, if the minute hand travels all the way around the circle, how much time has passed? 60 minutes, right? Yeah, the minute hand. Okay, so then we could do omega equals 2 pi over 60, so we get pi over 30. My units, theta was in radians, my time was in minutes. But there are other options. You know, if you had 60 minutes, isn't that the equivalent of 1 hour? So it might have, you could have had 2 pi over 1 or 2 pi radians per hour, and that would have also been an okay answer. Because this is in minutes, that's in hours. Or you could have done it in seconds. So make sure, I did this one partially really just to show you the importance of labeling your answer. There's a big difference if you're talking about radians per hour versus radians per minute. find S. If R is equal to 9 yards, omega is 2 pi over 5 radians per second, and t is 12 seconds. So find S. My formulas that involve S. S equals R theta. We have R, but we don't have theta. Or V equals S over T. We have T, but we don't have V. So we basically just have to pick a formula and find what we need. So which one do you want to go with? It's really about the same mark either way. We just went with the first one. S equals R theta. We need theta first. Look at the variables we have. What formula might help us find theta? Omega, 2 pi over 5 radians per second. So do a quick check. My time is in seconds, so I'm okay. Equals theta over 12. So multiply the 12. Theta is 24 pi over 5. Now we have theta, so we can do S equals R theta. My radius was 9 yards. My angle 24 pi over 5. So that gives me 216 pi over 5. Any questions on that? So, the plan, I'm going to go ahead and give you guys the homework. 3 through 35 is every other odd, so make sure you're not doing more work than you have to. Please label your answers, try to get in the habit of writing what formula you're using. This is going to be due on Wednesday. So you'll have some class time to work tomorrow. We might do a few more examples if we're needing it. We'll probably also practice filling out a unit circle with degrees, radians, and order pairs tomorrow. That's kind of a check to see where we're at with those. So tomorrow you'll